My name is Erin Kennedy, and I'm the CEO and technical founder of Robot Missions. It's really an honor that we're collaborating with this class to be able to build more modules for our robot. And during this presentation, what I'm going to do is give you an overview of what Robot Missions is all about. So that way it gives you a better understanding of what our vision is and how you can help us reach it as well. So to start off, what Robot Missions is doing is we are helping the planet using robots. So that sounds really lofty, but there are specific challenges. But first, let's start off with a video so that way you can see the robot in action. Okay, so what you saw there was the robot tackling the challenge of shoreline cleanup. Now, why shoreline cleanup? Well, the specific challenge of shoreline cleanup is that through our increase of consumption of plastic goods, we're seeing more of this wash up on our shorelines. And specifically the small items between 3 to 25 millimeters, these typically do not get collected by large machinery as well as with manual efforts. So what happens is that this type of debris ends up accumulating on the shorelines and harms our ecosystems and the surrounding wildlife. Birds typically tend to ingest this type of plastic as they mistake it for food, especially the small little red pieces because they look like berries. So what does this look like here in Ottawa? Well, what we have seen is that even though the City of Ottawa does clean up the beaches every single day using large machinery to drag the sand as well as daily cleanups during the summer, there is still this type of debris that ends up staying on the beach. This is just in one small area what we have found on Westboro Beach. And it was surprising to see the varying types of debris. A lot of them was small sized. You can see some of the cigarette butts in the containers. Of course, there is a cost associated with this because the large machinery has to be run, there has to be personnel to clean it up. So our thought process was that if we could deploy robots to help make this more efficient, we can reduce the amount of time personnel have to manually clean up, as well as save some costs. Now, what your class is going to be helping with is mission number 2. Mission number 2 is tackling environmental restoration. So imagine once shoreline cleanup is complete, or possibly in the same process during shoreline cleanup, the robots are also helping to restore the environment around it. What exactly does that mean? Well, imagine an arm or module on the robot to, say, plant grass seed. The robot could navigate around a park, deposit the seeds, and also possibly have another module or another robot to help water the seeds. There are some other ideas as well. For example, increasing pollinating plants, so that could be wildflowers. Tackling shoreline erosion, so manipulating land masses around shoreline erosion to help prevent that from happening. Observation for invasive species, such as little bugs that are on plant leaves. You may want to collaborate with the environmental science students to get more specific information on the details of that. And lastly, another important piece is sampling data. So if we are able to understand more about the nature around us, then we can determine how best to track this data, for example, water quality, and then hopefully mitigate it, mitigate the negative effects, that is. And so this can be done for both soil, water, and air quality, depending on which sensors you use. So what exactly is the solution that Robot Missions is providing? Sure, there's the robot, but how would this actually relate to a park department or an environmental organization? So the Robot Missions solution, it will bring increased productivity as well as a repository of data and active citizen engagement. Active citizen engagement comes from our public testing of the robots on beaches or in public parks, where we get volunteers to join in and help us in the testing process. How we deliver on this solution is through our 3 offerings of the robot platform, automation services, and environmental stewardship. So first off, the robot platform. Now, you may think that in order to tackle these large challenges, we would need a very large machine to do this, perhaps more of an industrial type of robot. But what our idea is to tackle this challenge by introducing low-cost robots. So that way it serves as a gateway entry for parks into automation, as they are currently not exploring this area. Some other values that this robot has compared to industrial type of robots is that it does have a relatively quiet operation. There's no large humming of the engines that would be in larger machines. As well, it's battery powered off of a battery that's similar to the type you would find in an aerial drone. It's extendable and repairable, as I'm sure you've already noticed. So since it is 3D printed, if something breaks, we can simply print one of those pieces to repair it. This reduces downtime quite dramatically, in that most pieces take less than 3 hours to print on a modest FDM type of printer that you'd find in the Makerspace here. It's extendable in the way that we use some common components in the design of the robot, so that way you can mount a module on various sides of the robot, as well as swap them in and out. And of course, the size of it is small. That means it is less intrusive than the large machines, so it can actually access the areas where debris can accumulate on shorelines. Now, here comes the fun part about the robots. In a way, the robots are like a delivery mechanism for the software that is running on it. So what Robot Missions is offering is to parks, environmental organizations, are automation services. Sort of, you could think of it like apps. So for example, one day in the future, it will be as simple as saying, Bowie, clean up this area of shoreline for 2 hours and then return back. We aim to deliver these types of services, including shoreline cleanup, baseline assessments, where you can take imagery of the shoreline to determine if this is an area that should be cleaned. And coming soon in this coming season would be environmental restoration, applying some of the modules that you all develop, as well as air quality monitoring. Environmental stewardship covers our outreach activities with youth, typically in elementary school grades 4 through 6. So we offer programs such as Adopt-A-Bot, which lets schools bring in this robot to their classroom for 1 month, as well as field tests, as I mentioned before, workshops for the students, and open source replication, which we are aiming to start doing in the coming month. So what exactly is this vision of the robots? Why are we trying to tackle this, and how do we see this growing and evolving? Our vision is that this robot will democratize the access to use this as a tool for many labs, universities, makerspaces in the world to tackle these environmental challenges. So if you could imagine, say for example, a library, you can borrow books at libraries. What if you could borrow this robot for a week and choose a specific module, some of the automation services, and bring it to your local park or even your backyard to perform some assessments, gather some data, and clean up or restore the natural spaces around it. That's our vision, and we would like to see at least 1 robot per park in Ontario by 2030. Okay, so now you're probably thinking, wow, this person might be a little bit crazy. How on earth is Robot Missions going to achieve this? Our global adoption strategy is to harness the power of fab labs and makerspaces to replicate the robot. Meaning, wherever there is a 3D printer in the world, we don't see a reason why this robot couldn't be replicated there, assuming we can ship the mechanical and electronic components as well. But that is one of the huge benefits. Because the robot can be printed there, we won't have to ship as large of a box than just, say, the little stuff as the motors and electronics. So the idea is that we would use these community groups to demonstrate to parks, environmental organizations, the value that this robot could bring to their local community. The challenges will differ depending on the communities, and so that's why it's important to go focus on a local perspective and replicate that globally. And then of course we would hopefully see that the park would be interested in implementing this solution and then do so on a yearly basis. And of course we would reward the group for their initial work to help us make that happen. Where we're at so far is we have engaged with over 250 participants during our field tests. People really see the potential of this idea, which is humbling and exciting because they do get a dose of how real robotics works in the field. Sometimes it doesn't work as expected, but then we improve and iterate on that experience. The robot so far has collected 3.1 kilograms of non-natural debris. It may not sound like much, but if you consider the fact that we are going for small sized, as well as when we were testing the robot, the prototype was still actively in development. So once that is complete, we would expect that number to increase. 1,200 meters have been traveled by the robot, so it's been roving along the shorelines quite a bit. And so far we have 5 robots replicated. One of them is even in Rochester, New York, so on the opposite side of Lake Ontario. It'll be great to one day see if there could be robots surrounding the perimeter of the lake That'd be pretty interesting. We had the opportunity to have one of the counselors from Ottawa join us on our field test. And their testimonial even highlights the part where robot mission serves as both an educational side as well as a tool for helping the environment. Our team is quite small, as you could imagine, for a startup, so I work on it full-time, and I'm joined by some other volunteers who donate their skills and time to assisting with the project. Now, the next step for robot missions is Municipal Trials. So searching out different locations to demonstrate our robot and solution to. We're aiming to be able to have a station set up on Westboro Beach to do this continuously every single day for about 4 hours to really test the robot embedded into the natural space. And as well with that, we'll be collecting a lot of environmental data, which will be interesting to track over the course of the summer. This covers just some of the impacts we would hope to see during the trials. I won't go through this in detail, but I just wanted to display it here so that you know there are specific measurements that we will be aiming for as we're doing the trial. It may look like robots will just be wandering around the park, but there are these measurements that we're hoping to achieve. Now, this is where your help comes in. So with the environmental restoration modules that you'll be creating, this will open a whole new area of what the robot can achieve and the difference that we could make in local parks around Ottawa and beyond. So depending on what is created and how replicable it is, we are aiming to have some of these used during the trial. So your designs will be put into the field. As well, keep in mind that having your design be created or manufactured for replication is important for the open source community as well. As you saw during the global adoption strategy stage or slide, since we are aiming to have the robots replicated in Fab Labs, it will be very important that your module can also be replicated there. That way more people can use it as a solution. Something that will change on a group-to-group basis will be how the impacts are measured for your module. So say, for example, for the scoop, we can easily measure how much debris could be collected per scoop and then extend that over time. For your module, it may differ. It may be how many grass seeds could be dispersed and then also count that over a certain area. As well, it could be about how many water samples could be collected before a person would have to exchange the test tubes or similar. This is an open and evolving project, so constructive comments. We received some of your great questions. Wild ideas and experiments are most definitely welcome. One of these robots is being replicated in the Makerspace, so throughout the duration of this class, Bowie will be being born, I guess, if that's how robots work, in the Makerspace. And we are on social media quite a bit, so if you want to just like snap a photo of any of your CAD designs or systems diagrams and share it online. And as your module comes into being reality, just share it on Twitter or Facebook with #RobotMissions. And if this is a vision that really resonates with you, it'll be great to have you a part of this movement that is beginning. So finally, the reason why we are doing this is because we believe we all have the duty to preserve our natural spaces. And Robot Missions is creating the way for many people within this nation to complete missions together using robots. So thank you, and looking forward to the questions.